homogeneity, something like that. All right, welcome back. This is 8-2, the chi-square tests and cautions, part 3. In this one, we're going to do the chi-square test for homogeneity. I can't say that one to save my life, but that's the one we're going to do nonetheless. So this is the area that we're going to look at. All right. Now, the procedures used in this, as it shows here, are the same as it is for 7-1. And they're a little harder to recognize sometimes, but you'll, again, have to just do lots of examples, or at least a few, to kind of see the differences here. All right, so these are used if the question of interest is whether the proportions in the different categories are the same in all of the groups. So here we go again. We have first bullet point. It's a simple random sample, basically, right? We're just talking about random like we always are. And then the second one, all groups are categorized by one variable. And that's where things get a little weird, because it's not just one row or one column. There's multiple rows and columns, but they're broken up into separate groups. And the one example we're going to show today, they're age groups, so you'll kind of see how that works. The hypothesis, the null hypothesis, will be such that the categories occur in the same proportions in all populations. Okay, and then the alternative hypothesis, at least two corresponding proportions differ. And that's what we're going to get into. So let's do it. All right, here's our problem. In a study of the snack preferences of children, a marketing firm selects a random sample of 90 children under 8, 150 children aged 8 to 10, 55 kids, blah, blah, blah numbers. Each individual is asked which of the following snacks they prefer: Doritos, Ruffles, or Cheetos. I'm going to have to go. Just depends on how I feel on a given day, I guess. Doritos is probably one of my all-time... Oh, they're not asking me. All right. Results are shown in the contingency table below. Oh, also, I'm not in these age categories. I don't know if you guys knew that, but let's start with the hypothesis this time, because usually that makes more sense. Let's get into that part. The null hypothesis would be, let's see, the proportions are the same in all four groups. And so by groups, I mean the different age groups, right? I think alternative hypothesis, the proportions are not the same in all four groups. And you could say that as in at least two of these groups are different. All right, conditions. This is the same as it's been. The subjects in each group were selected independently. So selected independently, and all cells have greater than 5. Each of these counts are greater than 5. These 10s are kind of close, but they're still greater than 5, so they're okay to use. Step 3, let's do the calculations. All right, so again, we're going to take the column total. I'm going to freeze the 9. I'm going to multiply that times the row total. I'm going to freeze the F. F. And then I'm going to divide that by the grand total. So I'm just going to freeze the whole thing, hit enter, and there's the numbers. So I'm going to drag that all the way across there and all the way down. Let's see, there's 1, 2, 3, 4 of them. All right, so these are expected counts. All right, now this is where we do the individual chi-squared. So we're going to take the actual minus the expected. We're going to square that, divide it by the expected, and voila, we have a number. We drag that across all these different cells, and we have a value for our chi-square. We just need to sum up this range. And there's our chi-squared number. Degrees of freedom is no different than it was for the 7-1 or the independence stuff. So we would take, let's just do the number. So 3, that's the number of rows minus 1. And then the number of columns minus 1 is 2. So we're going to have 6. All right. Then we're going to do this again. We're going to choose chi-squared dist RT. Put the x in there, comma, degrees of freedom, enter. And that's a number that's really close to 0. Okay. Cool. Very close to 0. And since that number is greater than probably any alpha that we were going to come up with, we can go ahead and reject the null hypothesis. Right? And then sentence of things explaining what that means in the context of this problem, and then you'd be done with it. That's it. That's what I'd like you to do for a final exam. These hypothesis tests. All right, so you've pretty much seen everything in part 3 that I wanted to show you, and we are done. So, having said that, we are done completely. I'm not gonna do any more videos except in the extreme circumstance that we have a problem that needs to be shown to everybody in a nice way. Then I might make another video. But for now, this is it. You have all the information that I care for you to have. Any more than that would be great. If you bring that on for yourself, certainly will be helpful. I will have information about the final exam here shortly as far as how it's going to work. But with that, I'm done. Hey, see you not in the next video. I don't know if I'll ever see you guys again. Hopefully I do. Hopefully I'll see some of you around campus someday soon, right? When we get to go back to it. All right. And with that, I bid you farewell, and I'll talk to you later. Bye-bye.